In this demo, we are going to analyze solar energy potential for building rooftops using high resolution elevation data based on DSM, that is Digital Surface Model datasets. So let's start a new session to execute the whole workflow. Before proceeding, let's rename our session based upon the objective of our study. Okay, for this demonstration, we have selected a small region in Miami-Dade County which has a good density of buildings and a strong solar exposure, making it ideal for the analysis. We would be working with two datasets, a DSM raster which represents surface elevations including buildings, trees, etc. and a building footprint layer for the same area in the Miami-Dade County. So let's start by uploading both the datasets into this session. Since DSM is a raster in GeoTIFF format, we will select the format accordingly and choose the file from our system. As you can see, the file is uploading. Let's wait for some time till it uploads completely. Great. As you can see, the file has successfully uploaded. Now, similarly, let's also upload the building footprints, which is a vector data in GeoParquet format. Now, both the datasets have been successfully uploaded into this session. Let's check our data catalog to see them. Here, both these datasets, the DSM data is sourced from the USGS national map and the building footprints are obtained from the OpenStreetMap. Both these sources are completely open source. Using these, we'll estimate how much solar energy each building rooftop can annually receive. So, let's begin by asking the system, that is the GriidAI agent, for to define the complete workflow for our objective. Here we are asking the agent to outline the complete workflow right from data preparation to solar modeling and finally the building level results which we need. This whole workflow overview will help us understand the complete logic for the whole procedure before actual execution. At present, the agent is outlining the complete plan which requires for our end-to-end execution. Here, as you see, the whole workflow includes the preparation of the DSM, extracting the rooftops for the DSM, calculation of the solar radiation, and aggregating the results to the buildings. Before directly jumping into the analysis, it is important that both the input data sets used for process are spatially aligned. This is a critical step as even small misalignments can lead to incorrect results. So let's ask the agent about it. As you can see, the agent is reading through the metadata of both these datasets. The result of it is that both the datasets are having same CRS. so no reprojection is required. Spatial extent and overlap are completely matching as well. So finally, the summary of the steps the agent carried out is: the only required alignment step is to rasterize the building footprints to a DSM grid before calculation of solar calculations. So the pre-processing steps as of now are completed. Before rasterizing the building footprints, we need to restrict our focus only on the region where rooftops are present. So we will mask out the DSM raster based upon the building footprint layer. Here, the agent is providing us the plan for masking out the building rooftops and asking for our permission to proceed. So let's proceed as of now. Here the agent is running the Python tool to extract or mask only the regions where for the DSM data where building rooftops are present, so that only building surfaces are considered for the solar analysis. The DSM raster has been successfully masked to include only building rooftop areas. Let's visualize the generated results and validate it further. Before proceeding for validation, let's actually map the whole DSM raster to get the proper idea. And overlay the building footprints on top of it. Okay, great. Now for validation of the newly generated results, let's close down the previous two layers and only see the rooftop DSM. This looks completely accurate. For now, let's hide the map and proceed further. Now let's move on towards the core part of our analysis, that is calculation of solar radiation for the year 2024 as the sample. As per the plan laid down by the agent, we are asking the agent to calculate the solar radiation for the year 2024. Let's see what the final plan of execution that the agent has come up with and validate it before giving the agent the permission to proceed. Let's proceed further. As you can see, the agent is executing the complete workflow. We are now calculating annual solar radiation, where the system is considering the rooftop slope, orientation, and shadow effects to estimate how much sunlight each rooftop receives. Behind the system uses an efficient approach that samples representative time periods across the year, allowing us to get accurate results without long processing times. As you can see, we have now a raster showing total solar energy potential across rooftops, which has been successfully generated by the agent. Now let's visualize and inspect the newly generated results. Let's inspect and validate the newly generated raster. Okay, let's move on further processing and hide the map as of now. Next, we need to convert the results generated from rasters into building level insights. Therefore, for each building, we need to calculate the average solar radiation, the total solar energy potential for the building, and the total rooftop area for the validation. Let's see what plan does the agent come up with to calculate the statistics for each building. As per our prompt, the agent is rightly selecting the tool zonal statistics to calculate mean total solar radiation for the building rooftop as well as the rooftop area. Let's grant the agent the permission to proceed. Great. The building level rooftop statistics have been calculated and a new file has been created with storing the results, where mean solar radiation well the average annual solar energy per square meter for the rooftop. Total solar radiation is the total annual solar energy received by the entire rooftop, and that is evident from its name is the rooftop area. Let's check the attribute table if the new fields have been correctly generated. As you can see, these fields are present inside the attribute table. Before moving forward, we need to validate these results. So let's check how many buildings have valid values and review the summary statistics the agent will generate. As you can see, the agent has generated the statistics based upon the building data. Only 10 of the total buildings are not having valid solar values, which is acceptable range. Apart from that, the range of the solar radiation is physically plausible as per the standards in this given region. The rooftop areas are even widespread range, but no outliers are there, so that is a good thing. And there are no signs for any type of alignment error. And the results generated are suitable for drawing further insights and generating reports. Now, to draw further meaningful insights from this building data, we need to classify the buildings based upon their solar potential to identify the high, moderate, or the low categories for the solar potential based upon the total solar energy the buildings can have. Let's ask the agent to do this. This three-tier classification scheme makes it easier to identify the buildings that are best suited for the solar installations. Let's see what the plan for execution the agent comes up with. The agent is going to filter out the buildings with the total solar potential and classify them into three classes based upon the three quantiles, that is top 25%, the middle 50%, and the bottom 25% as per our prompt. And a new field solar potential class will be added to determine the class for that particular building. Let's grant the permission for proceeding to the agent. Great, a new file has been created by the agent classifying the buildings into the three classes. Let's check the attribute table for the file to see. As you can see, a new class, solar potential class, for each building has been generated and defined into either low, medium, or high. Now let's visualize the results to see the distribution of the three classes in our study area. So let's ask the agent to create a thematic map based upon the categories by the solar potential. As you can see, the agent is running the tool to generate the thematic map as well as generate the statistics for the different classes for each building. As you can see, the agent has created the thematic map successfully. Let's visualize it first before looking at the statistics. Here, from based upon the thematic map, we can see that the red buildings represents the buildings which have high solar potential. The blue color represents the building which have low solar potential, and the green color represents the building having medium or moderate solar potential. That is the middle 50th quantile. Let's look at the statistics. There are close to 500 buildings in high and low categories, and the remaining ones are in moderate. Finally, let's analyze how the solar radiation varies throughout the year. Let's ask the agent about it. Analyzing the behavior of solar radiation throughout the year will help us understand the seasonal trends and identify the peak solar months. Let's see what plan does the agent comes up with. As you can see, the agent has computed the seasonal trends for all the months throughout the year 2024. As per the summary statistics drawn by agent, it is observed that the month of May has peak solar radiation and next highest is June. As expected, the solar energy peaks during the summer months and reduces slightly into the winter. The key seasonal insights, like for summer, it is close to 217 from the months for June to August, high and fairly stable. There is an annual peak in May and a fall in the late summer or early winter. And as expected, lowest month is December. And for the screening of the rooftops, the agent has further clarified that the best roof can be the ones which are driven by the spring-summer dominance, which is noticed with a noticeable dip in winter due to low sun angles and shorter days. Now, as we can see, in just few steps or very few prompts, we have transformed this raw elevation and building data into meaningful solar insights. This workflow can help planners, energy companies, as well as city authorities or other concerned stakeholders to identify the best locations for rooftop solar installations. And the best part, the entire process is automated, scalable, and easy to run using natural language prompts.